Hello everyone, my name is Prakriti. I am currently pursuing in Electrical and Electronics Department at PA's College of Engineering, Mandya. Symmetry property. Let us assume that a length n sequence x of n and its DFT x of k are both complex valued. So x of n is equals to xr of n plus j xi of n and x of k is equals to xr of k plus j xi of k. Here n and k varies from 0 to n minus 1. We know the formula x of k is equals to summation of 0 n is equals to 0 to n minus 1 x of n e to the power minus j 2 pi by n into k. That is k varies from 0 to n minus 1. Here we know the values of x of k and x of n. Substitute that values. So x of k is equals to xr of k plus j xi of k and x of n is equals to xr of n plus j xi of n. Then e to the power of minus j 2 pi by n into k as per the formula. So we know the formula that e to the power of minus theta is equals to cos theta minus j sin theta. So here we have e to the power of minus j 2 pi by n into k. So we get the formula like cos 2 pi by n kn minus j sin 2 pi by n kn. So here we have to multiply the each term, that is xr of n into cos 2 pi by n into kn, then xr of n minus j sin 2 pi by n into kn, then j xi of n into cos 2 pi by n into kn, then minus j square xi of n into sin 2 pi by n into kn. Here we get j square, so j square value is minus 1, so minus into minus plus, so plus xi of n into sin 2 pi by n into kn. So here we have to split the real terms and imaginary terms. Here you get confused like the suffix, the term which has the suffix I, it is also a imaginary term. That is not like that. The terms which has the coefficient the j, that only the imaginary terms. To split the imaginary and real terms. So here xr of n cos 2 pi by n into k, it is the real term, and also which doesn't have the imaginary term, that is j, that is xi of n sin 2 pi by n into k, it is also a real term. Then get the j as a common, then xi of n cos 2 pi by n into kn minus xr of n sin 2 pi by n into kn. Then here compare the real and imaginary parts, that xr of k is equals to these two terms and xi of k is equals to these two terms. Finally, here we take the high DFT formula, that is x of n is equals to 1 by n summation of k is equals to 0 to n minus 1 x of k into e to the power of plus j 2 pi by n into kn. Here n varies from 0 to n minus 1. So here we apply the same procedure as in the DFT. So we know the x of n and x of k, we split the formula e to the power of j 2 pi by n into k, and then we multiply the each term, and here we get the real terms and imaginary terms like this, that is 1 by n summation of k is equals to 0 to n minus 1 xr of k cos 2 pi by n into kn minus xi of k sin 2 pi by n into kn. Then imaginary terms like 1 by n summation of k is equals to 0 to n minus 1 xr of k sin 2 pi by n into kn plus xi of k cos 2 pi by n into. There are many cases in the symmetry property. Here I take only two cases. One is real and even sequence and real and odd sequence. Real and even sequence means the sequence which must be real and even. The condition for this real and even sequence is x of n is equals to x of n minus n is equals to x of mod of minus n. So we get the formula like x of k is equals to xr of k plus j xi of k. We know the values of xr of k and xi of k. Substitute the values. Then we have to get only real and even sequence. For real sequence, we have to cancel out the imaginary sequences like which has suffix I. So this also gets 0 and this one is also gets 0. So for even sequences, we know that cos is a even and sin is a odd sequence. So here sin is also gets 0. So we get the formula like summation of n is equals to 0 to n minus 1 x of n cos of 2 pi by n into kn. Here xr of n is equals to x of n, so we can replace the xr of n by x of n. So for real and odd sequences, we have the condition like x of n is equals to minus x of n minus 1 is equals to minus x of mod of minus n. So we know the formula like x of k is equals to xr of k plus j xi of k. Here also for real terms we have to get only real terms, so we can cut out the imaginary terms which has suffix I. So then we have the two terms xr of n cos 2 pi by n into k and then minus j xr of n sin 2 pi by n into k. So we have to get the odd sequence. So cos is a even sequence, we have to cos also. So we get this one. So here xr of n is equals to x of n. So we can replace the xr of n by x of n.